All right. So we have this picture. Lots of things are given. We have a rectangle with sides known, 3 and 5. And there are these two straight lines. And the question is, what is the area of this triangle? So the area of a triangle, first approach would be, well, how about base times height over 2? And so that means we should figure out this height and this line, which is much easier. This looks like 2 to me because this is 1, this is 2, that adds up to 3. And so what's left is 2 more needed for 5. So this here is 2, but to find this, that's going to take a little bit more work. So what I see that will probably work is that these two triangles are similar because, well, the right angle is easy, and then these two angles are the same. And also these two vertical lines are parallel. So we have the transversal case, but I think it's easier to see that, okay, these two angles are the same, and in a right triangle and another right triangle, just one match is enough, right? And then very similarly, we have a pair of similar triangles on the other side, but they're kind of run along parallel lines. This is not a center line if this triangle we're looking at is not isosceles. So that will give us a second unknown. So basically what I set up, I said, let this be M, and then this here is X, and then this here is 2 minus X, because we don't know how. This is how we write two numbers, X and 2 minus X, two unknown numbers that when added, we get 2. And so now let's see, M is something we're looking for, so we should include in our ratio problems. That's opposite this angle. In the other triangle, opposite that angle is 3. So basically M and 3 are corresponding. And then the hypotenuses seem to be useless, but the other sides aren't. And then the horizontal, it's kind of easy because the vertical with the vertical and the horizontal with the horizontal, you can check that the horizontal sides in both triangles are opposite the smallest angle. So that means that M corresponds to 3 and X corresponds to 1. So we can write M over X is 3 over 1. Or M is 3 times X. And that kind of makes sense. X has to be tripled, so it matches M. That looks reasonable given the picture. And then we rinse and repeat. So the same thing, M is with 3 in this other triangle, and then 2 minus X with 2. So M over 2 minus X equals 3 over 2. This is M. So we have two unknowns, two equations. That's encouraging. And they don't look so bad. They look linear. So when we cross multiply, here we get 2M equals to 3 times 2 minus X. That's 2M equals 6 minus 3X. You know what? Peeping the other equation, how about 2M is 6X, and then we substitute 6X into 2M here. That's usually the case, that the thing we're not looking for is easier to solve for, but it's not hard to solve from one to the other. So 2M is 6X. 6X equals 6 minus 3X. 9X is 6. So X is 6 over 9, which is 2 over 3. And then we look back, and 2 over 3 seems reasonable. This looks just a little shorter than the side that was labeled 1. So 2 over 3 is kind of reasonable. And that means that M is 3 times 2/3 or 2. So that means that we figured out early on that this horizontal side is 2, but now we also know that this vertical, this altitude is also 2. So the area is 1/2 times 2 times 2, which is 2. So that seems to be the answer. And then if you can, you should check. So it is the problem. Yeah, we got it right.